Hello. Man, I've been waiting a long time for you to show up. You're here. Where's that camera? There we go. All right, next example. So this time we're starting with the quadratic. And as we have said multiple times, no, quadratics are not one-to-one. So we need to, up front, determine how to restrict the domain so that it is one-to-one. Now, basically, you can restrict it in an infinite number of ways, and it's one-to-one. But we want to make sure that we keep the full range. However we restrict it, it has to have this range. I'm pointing at the screen there. Is the range after the domain restriction. And like you saw in the earlier example, we're just going to cut it in half at the vertex. It's a matter of whether the instructions tell us to use the left half or the right half. So we are specifically given instructions for decreasing. And again, if you have the parent function in your head, we know that this has not been flipped upside down. So the decreasing is going to be on the left of the vertex. So our domain restriction is going to, there you go. And like before, that is automatically the range of the inverse. Now this is, I think technically I label this as step 3. You can do it first like you see here. You can wait until later. Since we're doing the domain restriction to make it one-to-one, I'm just going to fill in the whole grid like that. The range, so again, parent function -2, shift down, tells me the range. That is the domain of the inverse. Now, if you do this first or you do it later, you can use this to double check your algebra. Because if I get the inverse function and its domain is not starting at -2, then mistake. That's the word trying to come out there. Boo-boo. Fix it. All right. So go through the steps just like before. And remember, whenever you solve for that square, you get that plus or minus. But if you keep that plus or minus, this isn't even a function. It's not just square root. So we need to figure out which one it is. So this is where the domain and range that we did earlier comes into play. So the range of the function, I'm pointing at the screen again, that we think is the inverse, starts at -infinity and goes up to -1. So if you think of the square root parent function and whether that range is the original or flipped upside down, and that tells you whether the which is plus or minus, like that. All righty, bum-ba-dum-bum. So the parent function starts at 0, goes up to infinity. Our range that we determined is supposed to start at -infinity, which means we did flip it upside down. So we use the minus in front of the root. Boom, write the answer correctly. Like that. Now, the other example, I explicitly in this answer, I'm pointing again, wrote the domain restriction. That was because it was a quadratic and it's not one-to-one. I have to include the domain. You have to include the domain restriction, but this is a square root, so the domain restriction is built in. Now, if you want to write, what was on the chart again, that's perfectly fine, but not required for this one. Required for the other example, not required for this example. And I'll see you around.